Hi guys. Okay, this is a video for anyone that missed class. Did you miss class Tuesday, Wednesday, or today? So I know like Seb, Andrew, and Jake are gone these 3 days, and I was gonna make them a package and totally forgot. So sorry guys. So I'll just tell you what you missed, if that would help. Okay, so on Tuesday, we had just Tutorial Tuesday, and we took the class outside, and we just graphed some functions. I feel like I've mainly been making you guys graph polynomial functions, so we just graphed like x cubed minus 2x squared plus 5x minus 7 or something. So we just graphed polynomials pretty much outside. Just did a bunch of practice stuff, practiced our long division if we needed it, just figured out what first and second derivatives do to help us graph things. Okay, then on Wednesday, yesterday, we looked at asymptotes a little more. So we looked at rational functions, and we also took up that quiz we did on the fancy paper. So we looked at horizontal and vertical asymptotes. So essentially we looked at 3 graphs. We looked at a graph where the degree on the top is smaller than the degree on the bottom. So like this. We also looked at the function on top and bottom is the same. So like 2x plus 1 over 3x minus 5. So same degree. Both are degree 1. Whereas in the blue one, degree 1 on the bottom is just a number on top. That was something we're not going to do much of, but we looked at where the top had a higher degree, which we don't get into too much this year. You get into it more next year. So like where degree is higher on the top. And we just summarized asymptotes for these things. So just to quickly summarize it for you, whenever we're finding vertical asymptotes, these guys are super straightforward. So for vertical asymptotes, we just set our denominator equal to 0 to find out what x can't be. So for this guy, our vertical asymptote would be x is equal to -1. For the green guy, our vertical asymptote would be x is equal to 5 over 3. And for the purple guy, our vertical asymptote would be x is equal to 5. So vertical asymptotes, no big deal. They're when the denominator equals 0 because we don't want it. Okay, then our horizontal asymptotes are a little bit different. So if you remember from last year, we kind of memorized if our degree was higher on the bottom, we memorized this thing. So in class, I just tried to explain it. I just tried to say horizontal asymptotes are when x is like a really big number, like infinity, or when x is moving towards a really small number, like negative infinity. So it's like looking at the extreme ends of the graph on the left and right. So let's just picture x being the biggest number you can think of. So say you had 2 divided by a gigantic number. If you're not really sure what it would be, just try punching it in on your calculator, and you'll see, I'm just gonna move this over, you'll see that it's approaching 0. So it's like we're using our limits to try to figure out a horizontal asymptote. Y equals 0 is our horizontal asymptote. Because as you punch in bigger and bigger numbers of x, values of x, the function's approaching 0. So that's our horizontal asymptote. So that's when we have a higher degree on the bottom. For g of x, it turns out like these constants over here don't really affect it too much. So if you think about a really gigantic number of x, 2 times a gigantic number divided by 3 times a gigantic number, the gigantic numbers kind of cancel out. Asymptote is just equal to the coefficient would be our horizontal asymptote. And then for this last case, we're not doing too much of it. We're not going to graph these at all. And so these are from first semester. We found out that they don't have horizontal asymptotes. No horizontal asymptotes. So they're going to have a different kind of asymptote that you can figure out next year. All right. And then, yeah, we just looked at graphing just different kinds of functions using first and second derivatives. So that was what we did on Wednesday. And in today's class, we are going to do some practice questions. So I'll leave them with you guys and you can try them while you're gone. So today's class, try to graph, and I'll post another video with answers. X squared times e to the negative x. See if you can graph that. And when you're graphing it, see if you can find out when the graph's concave up and down. So check out concavity. Find any inflection points. So try to sketch that guy. We're going to do this in class today. And the other one we're going to x plus Tues squared times x minus 1 to the 4th. And you could do the same thing. Find concavity, inflection points, and max and mins. Do the same thing and see if you can sketch the graph. So we're just going to try some crazy ones and just kind of look at, you know, our second derivative. This is our second derivative again. And our first derivative. So just using our first and second derivative to tell us some information about the graph so that we can try to sketch. So that's what we're going to do today. And if we have time, we might start optimization. So that's B1, optimization, which is B2, I mean. So we might start optimization, which is all about maximizing and minimizing things to get the optimum results possible given a fixed amount of stuff. So for example, you could be given a fixed perimeter. So maybe you're given like a fixed perimeter. You do these kind of questions in grade 9. And you want to maximize the area. So maybe you're given a perimeter of like 100 meters. And you build some kind of options. If you have 100 meters to go around the whole way, you could do like 20, 20, and subtract. What? 30. Would that, and then or you could do like a 10 by 40 or a 25 by 25. Like which one of these is going to maximize your area? So we're about to investigate this in class, but if you remember max and mins, we know that the derivative can give us max and mins on a graph. So we're going to be using that. So you want to first try to set up an equation. Conundrum. 2, try to find the derivative, set it equal to 0, and solve it, and it will give you the dimensions. Cool, so that's our plan for today. More on that later. Hope you guys are having fun if you're not in class, and hope this helped kind of cover up what we missed. So I'll make another video giving the answers to this stuff and talking about optimization.